Hi everyone, welcome to our channel and I hope you enjoy this video. The Retro Science channel subject section involves 4 domains: genetics, physics, biochemistry and biotechnology. Before we begin, I want to invite you subscribe and like the video and leave a comment. I'm very sorry for my accent and I thank very much NCI for allowing me to use this article. Today, cancer is a great worry in the world and as known incurable disease. Around us we see people suffer from cancer and chemotherapy methods. Cancer is a disease which some of body's cells grow uncontrollably and spread to other parts of the body. Cancer can start almost anywhere in human cell body, which is made up of trillions of cells. Normally, human cells grow and multiply to form new cells, and body needs them. When cells grow old or become damaged, they die, and new cells take their place. Sometimes this orderly process breaks down, and abnormal or damaged cells grow and multiply when they shouldn't. These cells may form tumors. Tumors can be cancerous or not cancerous. Consider a cell as a child. We can see it like infinity, and it makes cell division and multiply, but it causes cancer. But perhaps one day a cell can correct this mistake. Changes in DNA cause cancer. If we have tool to manipulation DNA to basic form or neutralize effect, we can cure cancer. Up to now discovered method of gene editing, but they are slow, error-prone, and expensive. In 2013, researchers showed that gene editing tool called CRISPR like a knife can cut piece of worm from your apple and you can eat it. This method can remove abnormal DNA sequence and rebuild DNA. Unlike all gene editing method, CRISPR is very accurate and easy to use, so that it can possible to edit all sequence genes in your high school without academic education. The new tool has markedly shifting the line between possible and impossible. Researchers test a cancer treatment involving immune cells that were CRISPR edited to better hunt down and attack cancer. Despite all the excitement, scientists are cautiously use this tool because CRISPR has good and dangerous potential, and it's very powerful genetic tool. So, how does CRISPR work? Like many other advances in science and medicine, CRISPR was inspired by nature. In this case, the idea was borrowed from a simple defense mechanism found in some microbes, such as bacteria. To protect themselves against attackers like viruses, these microbes capture pieces of attackers' DNA and store them away as segments called CRISPR. If the same germ tries to attack again, those DNA segments turn into short pieces of RNA. Help an enzyme called Cas find and slice up the attacker's DNA. CRISPR consists of a guide RNA and the Cas enzyme. When the guide RNA matches up with the target DNA, Cas can cut the DNA. Scientists designed the guide RNA to mirror the DNA of the gene to be edited, called the targets. The guide RNA patterns with the Cas and, through its name, leads Cas to the target. When the guide RNA matches up with the target gene's DNA, Cas can cut the DNA. CRISPR has become a go-to for scientists studying cancer. There's also hope that it will have a place in treating cancer. The first clinical trial of CRISPR for cancer. The first trial in the USA to test CRISPR-made cancer therapy was launched in 2019 at the University of Pennsylvania. The study funded in part by NCI, testing a type of immune therapy in which patients' own immune cells are genetically modified to better recognize and kill their cancer. The therapy involves marking genetic modification T cells, immune cells that can kill cancer. The goal of this study was first find out the CRISPR-made treatment was safe. It was tested in 2 patients with advanced multiple myeloma and 1 with metastatic sarcoma. A lot of questions about all the way that CRISPR might be put to use in cancer research and treatment. But one thing's for certain, the field is moving incredibly fast and new applications of technology are constantly popping up.
In 2 years or 5 years or 10 years?
I think we're making a lot of progress already. Just one really powerful example of a CRISPR application is that we can study genes and identify genes at much higher speed. So one experiment you can do is you can take a cancer cell line, and we know that cancer cell line, if you give it in a patient, if you give a patient a cancer drug, over time they'll become resistant to the drug, and so tumors will come back and the drug won't work anymore. An experiment we can do now using CRISPR is we can take the same tumor cells, use CRISPR to mutate every single gene in the genome systematically and comprehensively within a matter of 1 week, and then put a drug on, and then see what are the genes when mutated will make the cell resist the drug, so make the tumor grow again. And so we can do this by turning genes off, or we can do it by turning genes on using CRISPR. And this kind of new type of experiment will allow us to generate an encyclopedia of what in cancer type A, what are the mutations that make a drug resistant, in tumor type B, what kind of drug, and so forth. And that will really change the way that we treat cancer in the future.